Today we're going to cover adjusting the second generation hanger sensor. This is the mechanism that physically detects where newly scanned garments are loaded and continually checks that the current occupancy is accurate. It's imperative that this hanger sensor accurately detects which slots are occupied and which are not, and any inaccuracy is likely to cause misassemblies amongst other problems. Let's first take a closer look at the mechanical function of the hanger sensor. I've already removed the finger guard here, affixed with just two 4mm bolts that mount to these two support arms. As garments pass under the hanger sensor, the lever mechanism lifts, moving this tab in front of this barrel-shaped proximity sensor. The signal from this sensor is sent to the system's logic controller and it calculates the slot detected based on the current position of the conveyor belt. There's a number of points of adjustment that could affect this hanger sensor's accuracy, so let's go over those now. The first point of adjustment we'll cover is the in and out adjustment of the wheel and lever mechanism. If the lever is too far from the belt, a hanger may jump in its slot, causing the sensor to not trip for long enough for the time filter to register a hanger was detected. If it's too close, the lever and wheel might rub on the conveyor belt, causing it to not return to its resting position quick enough and keep the sensor tripped for too long. You can see the two bolts for adjusting the in and out position here. Once these two bolts are loose, you can move the entire L support bracket in or out, moving the wheel and lever assembly closer or further away from the belt respectively. Our goal is to get the wheel and lever as close to the conveyor belt as possible without it rubbing on the conveyor belt. Now that we've set the in and out position of the wheel and lever assembly, we can now set the pitch and height of it. We want to ensure the wheel and lever are sitting as level as possible. This horseshoe-shaped cam pinches onto the end of this shaft, connecting it to the wheel and lever assembly, locking their movements together. The top of the cam presses against this small stopper piston, which in turn sets the resting position of the wheel and lever. In order to change the resting position, you'll need to loosen the bolt on the end of the cam, and with this loose, the cam can move independently of the wheel and lever. Hold the cam against the end of the stopper piston like so, and lift or lower the edge of the wheel and lever assembly as needed. Once you have the lever sitting level, tighten the cam bolt back down to lock the position in place. The height of the wheel and lever can be set with these two bolts on the front of the hanger sensor. We want it positioned so that the very bottom of the yellow wheel sits right at the same level as the bottom of the conveyor slots. This one appears a tad high, so by loosening the two aforementioned bolts, the mechanism can now be raised or lowered as needed. Once you have your height set, lock the two bolts on the front back down. Next we'll go over the adjustments for the straightener plate. This is a large trapezoidal plate underneath the hanger sensor. As the name implies, the straightener plate helps keep hangers straight as they pass through the hanger sensor. If they twist too much as they pass through the hanger sensor, the weight of the wheel can cause hangers to jump out of place, giving another avenue to cause misreads. As you can see, the straightener plate here isn't touching the hangers at all when perpendicular with the slot, so we'll move this one out using the two bolts on the bottom. Just crack these two bolts loose and you can slide the straightener plate in or out on these two cammed slots underneath, making sure to keep the straightener plate parallel with the belt. While not shown here, you should test with your hangers and make sure that hangers rest on the outside edge of the straightener plate and it pulls the hangers perpendicular to the conveyor belt. Lastly, make sure that these two bolts are tightly snugged, that way you don't have anything potentially shift going forward. Lastly, we'll set the height of the sensor itself. The sensor is this threaded barrel-shaped piece resembling a spark plug seen here. The height of this sensor affects the sensitivity of the entire mechanism. Pushing the sensor higher results in it being less sensitive, and lower makes it more sensitive. If you're seeing erroneous slot empty errors, you want the sensor to be more sensitive, ergo move down, and vice versa if you're seeing erroneous remove item errors. To move the sensor, you can take an adjustable open-ended wrench with the jaw width set to about 19mm and seat that on the mounting tab for the sensor. This should give you enough leverage to move the sensor without loosening any mounting bolts. Generally, I like to have the sensor raised just about a millimeter or two above the highest spot where the sensor triggers with the lever in its resting position. Now that we've covered all the major adjustments and how to set them, we can go over how to test your hanger sensor for accuracy. We do this by forcing remove item errors and then ensuring that only the slot you place a hanger in triggers the slot empty error. If you're using an empty hanger, be sure to lightly hold the hanger in place to simulate the weight of a garment on the hanger. As you see here, we've placed a hanger in slot 140 and received an error for only that slot. We'll next want to repeat the same test but in the extreme edges of the slots. So pull your hanger left in the slot so that the hanger pulls to the top of the V groove at the bottom of the slot where it meets the vertical dividers between the slots. Now that we have our hanger pulled to the side in a slot, clear the previous air and allow the hanger to pass through the hanger sensor. As you see, we've held this hanger to the left side in slot 128, and the air only occurred on slot 128. Now repeat this same test for the right-hand side of the slot as well. Keep in mind that you may need to move with the conveyor when you're testing the edge that is in the direction of the conveyor movement. When testing the outer edges of the slot, what we're looking for is to see if we get a second air for either of the neighboring slots. Continue to repeat this test until you're sure there's no erroneous airs except for the slot you're forcing the air on. Should you have an erroneous air that triggers on a second slot, this indicates that the phasing, or the left-right position of the hanger sensor, might be off. If the erroneous air occurs in the slot following the one you forced an air on, that indicates that the window for detecting a hanger in a specific slot is too late, and vice versa if the erroneous air occurs in the slot ahead of the one you tested with. While this sounds counterintuitive, you want to move the hanger sensor towards the slot you had the erroneous air on. For example here, we just forced an air on slot 305. Had we triggered airs for both 306 and 305, we'd want to move the hanger sensor to the right in this instance. You can adjust its position by loosening these two bolts from the underside of the hanger sensor, which each connects to an S bracket, pinching the hanger sensor onto the conveyor track. Start with small adjustments, moving by just a millimeter or two at a time by gently tapping on the structure with a mallet. I also find it helpful to mark its original position on the track so you have a reference point for how far you've moved it. Lock down the position and retest on the edges of the slots as we did earlier. Once you're confident that your phasing adjustments have eliminated any erroneous airs, double check that any fasteners you may have loosened are snugged, and lastly replace the finger guard on the hanger sensor. This should cover all the potential adjustments and points of errors of your hanger sensor, and if this guide is followed to the T, should eliminate any and all inaccuracies. If you're still struggling, or any explanation here covered is unclear, don't hesitate to reach out to the MPUSA support team.